most of what we do these days, our methods, our theories, our ideas, are shaped to some extent by Piaget's influence. And so what I want to do is begin this class that's going to talk about cognitive development by talking about his ideas. His idea was that children are active thinkers. And incidentally, to know where he's coming from on this, he had a very dramatic and ambitious goal. He didn't start off because he was interested in children. He started off because he's interested in the emergence of knowledge in general. It was a discipline he described as genetic epistemology, the origins of knowledge. But he studied development of the individual child because he was convinced that this development will tell him about the development of knowledge more generally. There's a very snooty phrase that, I don't know if you've ever heard it before, it's a great phrase. It's ontogeny recapitulates phylogeny. And the idea of this, what that means is that development of an individual mimics or repeats development of the species. Now, it's entirely not true, but it's a beautiful phrase. And Piaget was committed to this. He was very interested in saying, look, we'll figure out how a kid develops, and that will tell us about the development of knowledge more generally. So Piaget viewed a child as a scientist who developed these understanding, these schemas, these little miniature theories of the world. And they did this through two sorts of mechanisms: assimilation and accommodation. So assimilation would be the act of expanding the range of things that you respond to. Piaget's example would be a baby who's used to sucking on a breast might come to suck on a bottle or on a rattle. That's changing the scope of things that you respond to. Accommodation is changing how you do it. A baby will form his mouth differently depending on what he's sucking on. And so these processes where you take in, I'm giving this in a very physical way, but in a more psychological sense, you have a way of looking at the world. You could expand it to encompass new things, assimilation. But you could also change your system of knowledge itself, accommodation. And Piaget argued that these two mechanisms of learning drove the child through different stages. And he had a stage theory, which was quite different from the Freudian stage theory that we've been introduced to. So his methods were to ask children to solve problems and ask them questions. And his discoveries that they did them in different ways at different ages led to the emergence of the stage theory. So for Piaget, the first stage is the sensory motor stage, or the sensory motor period. For here, the child is purely a physical creature. The child has no understanding in any real way of the external world. There's no understanding of the past, no understanding of the future, no stability, no differentiation. The child just touches and sees, but doesn't yet reason. And it's through this stage that a child gradually comes to acquire object permanence. Object permanence is the understanding that things exist when you no longer see them. So those of you in front, you're looking at me, and I go. It occurred to me to be a great magic trick if I then appeared in back. But no, I'm just here. That's object permanence. If I win under here, and then the people said, where the hell did he go? Class is over. That would show a lack of object permanence. So adults have object permanence. Piaget's very interesting claim is that kids don't. Before 6-month-olds, Piaget observed, you take an object the kid likes, like a rattle, you hide it, you put it behind something, it's like it's gone. And he claimed a child really thinks it's gone. Things don't continue to exist when I'm not looking at them anymore. And so he noticed they're surprised by peekaboo. And Piaget's claim was one reason why they're surprised at peekaboo is you look at the kid's smile and you go, oh, peekaboo, and you cover your face, and the kid says, he's gone. Peekaboo, oh, there he is. He's gone. And he really, that's the claim. Piaget also discovered that older children fail at a task that's known as the A not B task. And Peter Gray, in his psychology textbook, refers to it as the changing hiding places problem, which is probably a better name for it. And here's the idea. You take a 9-month-old, and for Piaget, a 9-month-old is just starting to make sense of objects and their permanence. You take an object and you put it here in a cup, where the kid can't see it, but it's in the cup. So the kid, if you're the kid, will reach for it. You do it again, reach for it. You do it again, reach for it. That's point A. Then you move it over here. Piaget observed kids would still reach for this. It's like they're not smart enough to figure out it's not there anymore, even if they see it moved. And this was more evidence that they just don't understand objects. And this thing takes a lot of time and learning to develop. The next stage is the pre-operational stage. The pre-operational stage, the child starts off grasping the world only in a physical way, in a sensory motor way. But when he gets to the pre-operational period, the capacity to represent the world, to have the world inside your head, comes into being. But it's limited, and it's limited in a couple of striking ways. One way in which it's limited is that children are egocentric. Now, egocentrism has a meaning in common English, which means to be selfish. Piaget meant it in a more technical way. He claimed that children at this age literally can't understand that others can see the world differently from them. So one of his demonstrations was the 3 mountains task. You have 3 mountains over there. You put a child on one side of the mountains and you ask him to draw it. And like a 4 or 5-year-old can do it easily. But then you ask him to draw it as it would appear from the other side. And children find this extraordinarily difficult. They find it very difficult to grasp the world as another person might see it. Another significant finding Piaget had about this phase of development concerns what's called conservation. And the notion of conservation is that there's ways to transform things such that some aspects of them change, but others remain the same. So for instance, if you take a glass of water and you pour it into another glass that's shallow or tall, it won't change the amount of water you have. If you take a bunch of pennies and you spread them out, you don't get more pennies. But kids, according to Piaget, don't know that. And this is one of the real cool demonstrations. Any of you who have access to a 4 or 5-year-old, a sibling or something, do not take one without permission. But if you have access to a 4 or 5-year-old, you can do this yourself. This is what it looks like. The first one has no sound. The second one is going to be sound. It's going to come on at the end. But there's 2 rows of checkers. She asked the kid, which one has more? The kid says they're the same. Then she said, now she asks him, which one has more? That or that. So that's really stupid. And it's an amazing finding. Kids will do this, and it's a robust finding. Here's another example. So they're the same.
Which one is the most water? That one has the most water in it now?
So it's a cool finding of that stage, suggesting a limitation in how you deal and make sense of the world. The next phase, concrete operations from 7 to 12, you can solve the conservation problem, but still you're limited to the extent you're capable of abstract reasoning. So the mathematical notions of infinity or logical notions like logical entailment are beyond a child at this age. The child is able to do a lot, but still it's to some extent stuck in the concrete world. And then finally, at around age 12, you could get abstract and scientific reasoning. And this is the Piagetian theory in very brief form. Now, Piaget fared a lot better than did Freud or Skinner for several reasons. One reason is these are interesting and falsifiable claims about child development. So claims that about failure of conservation in children at different ages could be easily tested and systematically tested. And in fact, there's a lot of support for them. Piaget had a rich theoretical framework, pulling together all sorts of observations in different ways, wrote many, many books and articles, and articulated his theory very richly. And most of all, I think, he had some really striking findings. Before Piaget, nobody noticed these conservation findings. Before Piaget, nobody noticed that babies had this problem tracking and understanding objects. At the same time, however, there are limitations in Piaget's theory. Some of these limitations are theoretical. It's an interesting question as to whether he really explains how a child goes from a concrete thinker to an abstract thinker, or how he goes from not having object permanence to understanding object permanence. There's methodological limitations. Piaget was really big into question and answer. But one problem with this is that children aren't very good with language. And this might lead you to underestimate how much they know. And this is particularly a problem the younger you get. Methodology is going to loom heavy in the discussion of any science, and that includes psychology. Often, 90% of the game is discovering a clever method through which to test your hypotheses. Well, we're going to talk a little bit about that regarding babies. I'll give you another example from a very different domain. There was a set of scientists interested in studying tickling. So when you tickle somebody, under what circumstances will they laugh? Where do you have to tickle them? Can you tickle yourself? Does it have to be a surprise? And so on. It turns out very difficult to study this in a lab. You're not going to have your experimental credit. You come into the lab and say, okay, I'm the graduate student. And in fact, an example of a methodological attempt was done by Henry Gleitman at University of Pennsylvania, who built a tickle machine, which was this box with these two giant hands that went and this was a failure because people could not go near the tickle machine without convulsing in laughter. But we will discuss, when we have a lecture on laughter, a bit of the tickle sciences. And finally, there's factual. What do infants and children really know? It's possible that due to the methodological limitations of Piaget, he systematically underestimated what children and babies know. And in fact, I'll present some evidence suggesting that this is, in fact, the case. So I want to introduce you to the modern science of infant cognition. Infant cognition has been something studied for a very long time. And there's a certain view that has had behind it a tremendous philosophical and psychological consensus. And it's summarized in this Onion headline here. And the idea is that babies are stupid, that babies really don't know much about the world. Now, the work that this Onion headline is satirizing is the recent studies, which I'm going to talk about, suggesting that on the contrary, babies might be smarter than you think. And to discover the intelligence of babies, we have to ourselves be pretty smart in developing different techniques. To study what a baby knows, you can't ask it questions. Babies can't talk. You could look at what it does, but babies are not very coordinated or skilled. So you need to use clever methods. One clever method is to look at their brain waves. This child on the right died during testing. It was a tragic, crushed by the weights of the electrodes. He's happy, though. You can study their brain waves. One of the few things babies can do is they could suck on a pacifier. And you might think, well, you know, how can you learn anything from that? Well, for instance, you could build machines that when babies suck on a pacifier, they hear music or they hear language. And then you could look at how much they suck on the pacifier to determine what they like. But undeniably, we got most of our knowledge about babies from studies of their looking times. That's one thing babies can do. They can look. And I have up here, this is a picture of Elizabeth Spelke, who's a developmental psychologist who's developed the most research on looking at babies' looking times and what you could learn from them. And I have here two ways you could learn from looking. One is preference. So for instance, suppose you want to know, for whatever reason, do babies like the looks of dogs or cats? Well, you could put a baby down, have a picture of a dog here, a picture of a cat here, and see which one the baby looks at. Babies can move their eyes, and that could tell you something. Do babies distinguish pretty faces from ugly faces? Well, put a pretty face here, an ugly face here. See if the baby prefers to look at the pretty one. You could also do habituation and surprise. And much of the studies I'm going to talk about here involve habituation and surprise. Habituation is a fancy word for boredom. What you do is you show a baby something over and over again. Now remember, from behaviorism, the baby will learn this isn't very interesting. Then you show the baby something different. If the baby really sees it as different, the baby will look longer. And you could use that as a measure of what babies find different. For instance, suppose you want to know if a baby can tell green from red. Well, you could show the baby a green patch, a green patch, a green patch, a green patch. Baby will get bored. Then a red patch. If they all look the same to the baby will just continue to tune out. But if the red looks different, the baby will perk up. And this is, in fact, one way they study color vision in babies. Surprise is related to this. You could show babies something that shouldn't happen. If babies also think it shouldn't happen, they might look longer. And essentially what happens is scientists do magic tricks to explore this very thing. And to start with some real examples, a lot of this infant research has gone back to the Piagetian question of object permanence, asking, is it really true babies don't know that objects remain even when they're out of sight? So one very simple study by Spelke and by Argent had babies shown a block with a bar going back and forth, like that. So the bar just goes back and forth. Now, there's something you do that's so obvious you probably don't even know you're doing it. When you see a display like that, what you assume is there's a bar there. And what that means is there's something in the middle that you've never seen before. But of course, if you were a simple perceptual creature, you would just see that there'd be a bar on top and a bar on the bottom. You wouldn't expect anything in the middle because you never saw anything in the middle. So what you do then is you show babies this, and then you show them either B or C. And if we do this with adults, you expect B. C is almost a joke. And in fact, babies respond the same way. Babies expect there to be an entire, complete bar and are surprised and look longer at the broken bar. Other studies, some of them, well, here's another study by René by Argent looking at the same thing in a different way. You show the baby, say a 6-month-old, a stage with a block on it. Then a screen rises and obscures the block. Now, if the babies expect the block to still be there, they should think the block should stop the screen. On the other hand, if out of sight, out of mind, they should expect the screen to keep going. So what you do is you set up a couple of displays, one where the block is stopped, the other one where you take this away with a trap door, and it keeps going. And as you see, the baby screams when this happens. That doesn't really happen, but they do look longer. One final example of an object permanence study, some of this work's been done at Yale in Karen Wynn's lab, where they look at babies' understanding of addition and subtraction. And a lot of it is done with real objects, but there's also animated versions. So here is an animated example. Babies are surprised. They expect 2 minus 1 equal 1, and when 2 minus 1 equals 2, or 3, or 0, they look longer, indicating surprise. And even 6-month-olds are sensitive to these rudimentary facts of arithmetic, telling us something about their mathematical knowledge, but also telling us something about that they expect things to remain when they're out of sight. Now, this research suggests that infants' understanding of the physical world is there from the very start, but at the same time, not entirely. We know there's certain things babies don't know. Here's an example. Suppose you show babies this. You have a block here, and they have something above there, floating in midair. Babies find this surprising. Even 6-month-olds find this surprising. It violates gravity. But 6-month-olds aren't smart enough to know that a block just stuck over here is also surprising. 12-month-olds will think that it should fall. 6-month-olds don't. And even 12-month-olds don't find anything weird about this, while adults are sophisticated enough to understand that that's an unstable configuration and should fall over. So although some things are built in, some things develop. And this raises the question of how do we explain development? How do we explain when babies come to know things that they didn't originally know? Well, one answer is neural maturation, growth of the brain. Most of the neurons you have now in your head, right now, you had when you were in your mother's uterus. What happens in development isn't for the most part the growth of new neurons, it's for the most part pruning, getting rid of neurons. So the neural structures change radically as babies kind of get rid of excess neurons through development. At the same time, though, connections between neurons grow like crazy. And this process of synaptic growth, where there's the connections across different synapses, peaks at about 2 years. Finally, remember myelination, where you sort of get this fatty sheath over your neuron to make it more effective? That also happens through development. And in fact, it goes through development, and even teenagers are not fully myelinated. In particular, they're not fully myelinated in their frontal lobes. Recall that frontal lobes are involved in things like restraint and willpower. And so it could be the problem is the baby's brain doesn't develop yet. Another possibility is there's problems with inhibition. This is related again to the frontal lobes, and this comes up with the A not B error. So remember, the baby reaches, it's moved, keeps reaching the same place. And it could be that babies don't know anything about objects. But another possibility is once you do something, it's kind of hard to stop. It takes a bit of control to stop. And there's all sorts of independent evidence that babies lack this control. A part of their brain that could control certain behaviors is just not active yet. There's a very nice illustration of inhibitory problems from a Simpsons episode that actually sort of covers anything you might want to know about developmental differences. Basically may sum up much of developmental psychology. That the child essentially, he does A, it's moved, and he goes, no, and he keeps going for it. And there's some evidence that's true. Adele Diamond, who studied this, finds that although kids reach for A, they look for B. As if they know it's there, but they can't stop themselves from reaching. And we'll continue this theme a little bit later. Finally, it might be kids don't know things. Some things you gotta learn. And this is true in all sorts of domains, in the social world, in the economic world, in the political world, and it's true as well in the physical world. In fact, there's some things even adults don't know. So here's a study by Michael McCloskey with college students. Here's the idea. You have a tube, a transparent, a tube, a hollow tube. And at the top of the tube, you throw a ball through. So whips through the tube and comes out. Question is, what happens to it? Does it go in the path of A, or does it go in the path of B? Without looking around, who votes for A? Who votes for B? Here's the weird thing. Whenever I do this at Yale, everybody gets the damn thing right. At Johns Hopkins, 50-50 went for A and B. I got to get a better demo. But anyway, college students not here show systematic biases of incorrect physical intuitions. Here's a twist. And if you found people who were less wonderful than you all and asked them, you'd get a lot of people saying the curving thing. But here's the twist. Ask somebody, what if you took a tube and you squirted water through it? Where would the water go? Nobody chooses B. Everybody knows the water would continue in a straight line, suggesting that when you have experience, that helps you out. But in absence of experience, you're kind of lost. we've talked about the physical world. What about the social world? What about the world of people? Well, there's a lot of research on this as well. Babies start off with some social preferences. If you take newborn babies, it's very hard to do research with newborn babies, actually, because of the consent procedure and everything. So most of this work is done in France, where they have no laws at all. They just rush into, women give birth, and rush into, say, you're a psychologist, and then they do experiments on the babies. And it's terrific. And this is like one of them, where they compare babies looking at this versus this. Babies like the one that looks like a face. These are newborns. There's some preferences with humans and with other primates to favor faces. Babies are also social animals, too. So they're natural mimics. Andrew Meltzoff, for instance, has found that if you go to a newborn baby, and if you find a newborn baby, this is the first thing you should do. Stick your face right up to newborn baby and go, and stick your tongue out. And Meltzoff finds that babies, more often than not, stick their tongues out back, suggesting some sort of social connection from one person to another. And then later on, babies are mimics. Babies, more often than not, will copy the face next to them. Now, the nature of these responses, this preferring faces, this sort of mimicry, is a matter of debate. And there's a lot of research going on asking how smart are babies? Can we use some of the same methods that we've looked at for the physical world to look at the social world? And to illustrate one of the studies, I'll tell you about a study that I did with Valerie Kuhlmeier and Karen Wynn. And so what we tested was 9-month-olds and 12-month-olds, and we showed the movies. So they're sitting down and they're seeing a movie where one character is going to help a ball achieve a goal and another character is going to hinder the ball. And then we're going to see whether they expect the ball to approach the one that helped it versus the one that hindered it. So this is what a baby would see. This is literally the same movie a baby would see in the experiment. The thing is, for these sorts of experiments, there's a lot of control. So something that's a square in one movie will be a triangle in another movie. Something that's on the top in one movie will be on the bottom in another movie. So this is an example movie. But this is what babies would see. And they see this over and over again. And the question is, would babies expect the one to approach the one that helped it? Or approach the one that hindered it? And what we find is, statistically, babies look longer when shown a movie where it approaches the one that hindered it versus helped it. And this we take as preliminary evidence that, they have a social interpretation. They see this movie as you see this movie, in terms of helping and hindering, and somebody going to somebody that helped it versus hindered it. You could then ask, this makes a prediction, that babies should themselves prefer the creature who's the helper versus the hinderer. And to explore this, a graduate student in this department, Kylie Hamlin, has started a series of studies where they show babies three-dimensional scenes and then give them the characters and see which one they reach for. So here's video, so you can see how this experiment is done. Now, the next trial is from a different study, different things were used, and the baby's given a choice. And one thing to know methodologically is the person giving a choice is blind to the study. And blind here is a technical term, meaning she had no idea what the baby saw. And the point about this is to avoid either intentional or unintentional sort of trying to get the answer you want. She couldn't do that because she didn't know what the right answer is. So here's what the baby would see.
Which toy do you want to play with the blue one? All right, good job, Ryan. All right.
So this suggests that some social understanding may be there from the very start. This evidence is tentative, very controversial. But now I want to raise a huge developmental puzzle. And the puzzle is, there are some ways in which babies are, not just babies, but young children, are very clueless when it comes to people. And so I have a film clip here of two very nice studies showing young children's ignorance of other people. I'll show you the studies, and then we'll briefly discuss what they mean. Before discussing that example in a little bit more detail, any questions? What are your questions? Yes, and back.
What were the age differences between those two children?
Typically, I don't know for those particular children, but typically on those tasks, 3-year-olds and young 4-year-olds tend to fail. And around the age of 4 or 5, kids tend to succeed. There's sort of a period around the age of 4, 4.5, where kids make the transition from failure to success. The question, by the way, was when do children, in that video, what were the ages of children who failed and who passed? Yes? Tomorrow. No,
In the textbook, there was, last chapter, there was some discussion of discriminant conditioning and using that to figure out like what concepts animals had. Has that ever been used with babies?
The question of whether discriminant conditioning has been used with babies to explore what sort of concepts they have, I don't know. Does anybody? It has been.
It's not as effective as other techniques.
Colleen answered and said that it's not as effective as other methods. Part of the problem with using operant conditioning with babies is it's difficult to get them to behave in any systematic way. So the looking time measures tend to be more subtle. Any other questions? Oh, yes.
Did they look at why both of those young boys chose the rocket ship one versus the...
The question of why they chose the kids chose the rocket ship one as opposed to the Raphael one. It wasn't what they were interested in an experiment. My bet is when they chose the stickers, they had a pretty good sense of which ones the boys would prefer in those studies. The question of why a boy might prefer one sort of sticker and you might get a different response with a girl is going to come up later when we discuss different theories of sex differences. But that was something I think they were just assuming in the study to get it off the ground. Okay. There's a huge debate over what's going on there. And if you listen at the end to the psychologist summarizing the data, the psychologist had a very good and very clear and strong idea of what was going on. It was that children need to know more about minds. The children don't know about that you can do something with the intent to deceive. They don't understand that somebody could choose what you chose in a malicious way. This is possible. This is one respectable theory. But the alternative is they have the right knowledge, but they suffer from problems with inhibition. So consider both studies. The first study, the one of the deceptive dolls with the big shoes and little shoes, is actually fairly difficult. And it's possible that children kind of got overwhelmed with it. And when asked what would the mother think, who the mother would think stole the food, responded with who really stole the food. And that there's some pull towards the right answer that makes this task difficult. The second study illustrates this issue even more clearly. Take the boy who kept failing. He kept pointing to the rocket ship, and Mean Monkey kept taking it away. It's possible that he genuinely didn't know what to do, that he wasn't smart enough to understand that he needed to point to the other one. But it's also possible that it's a Homer Simpson-like effect, where when asked to point to what he wants, he just couldn't help but point to the one he wanted. And that the extra work it takes to lie was beyond him. And in support of the second alternative, even adults find these tasks involving lying and deception more difficult. We're slower at them, we make more mistakes than tasks that don't involve lying and deception. So I'm raising this not to solve the problem. You'll read more about it in the Peter Gray textbook and more about it in the Norton readings on development. But just to raise this as an interesting area of debate. Another interesting area of debate is what's the relationship between different sorts of development. So I started off with Piaget, and Piaget, like Freud, believed in general across-the-board changes in how children think. An alternative, though, is that they're separate modules. And this is a view developed again by Noam Chomsky and also by the philosopher of mind, Jerry Fodor, who claim that the whole idea of a child developing as a single story is mistaken. What you get instead is there's separate pre-wired systems for reasoning about the world. These systems have some built-in knowledge, and they have to do some learning. But the learning pattern varies from system to system, and there's a separateness to them. Why should we take this view seriously? Well, one reason is that there are developmental disorders that seem to involve damage to one system, but not to another. And the classic case of this is a disorder known as autism. And autism is something I've always found a fascinating disorder for many reasons. It's actually why I entered psychology. I started off working with children with autism. And it could be taken as a striking illustration of how the social part of your brain is distinct from other parts of your brain. So what autism is a disorder that strikes about 1 in 1,000 people, mostly boys. And the dominant problems consist of a lack of social connectedness, problems with language, problems dealing with people, and more generally, problems with what the psychologist Simon Baron-Cohen has described as mind blindness. In that autistic people show no impairments dealing with the physical world. They show no impairments on, they don't necessarily show any impairments on mathematical skills or spatial skills, but they have a lot of problems with people. Now, many autistic children have no language, they're totally shut off from society, but even some of them who learn language and who manage to get some sort of independent life, nevertheless, will suffer from a severe social impairment. And this could be shown in all sorts of ways. A simple experiment developed by Simon Baron-Cohen goes like this. You show this to 3- and 4-year-olds. There's 4 candies there, and you say, this is Charlie in the middle. Which chocolate will Charlie take? For most children, and most of you, I hope, the answer is pretty clear, this one. Autistic children will often just shrug, say, how could I know? Because they don't instinctively appreciate that people's interests and desires tend to be attuned to where they're looking. Another sort of task, which is a task that's been done hundreds, perhaps thousands of times, is known as the false belief task. And here's the idea. You show the child the following situation. There's a doll named Maxie, and Maxie puts the ball in the cupboard. Maxie leaves, and a second doll enters. The second doll takes the ball out of the cupboard and puts it under the bed. Maxie comes back, and the question is, where will Maxie look for the ball? Now, this is a question about your understanding about minds. The question of where is the ball really is a question about the physical world. Everyone can solve it. But this question is hard. The right answer is Maxie will look in the cupboard, even though it's not really there. because Maxie has a false belief about the world. 3-year-olds find this difficult. 2-year-olds find this difficult. 4-year-olds and 5-year-olds are able to pass this task. Normal adults are able to pass this task. Children with autism have serious problems. And often people with autism who are otherwise very high functioning will fail this task. They'll say, oh, he must think it's on, he's going to check under the bed. Any questions about autism? Yes?
How is that example with the ball moving from the cover to the bed different from what we watched with the Katie and John walking through the class?
Good question. It isn't. They're both experiments designed to tap an appreciation of false belief. The deception one, with the shoes and everything, looked at it in the course of deception. Can you understand that a mother might think it's that person, even though it's really that person? And our kid failed. This is a sort of stripped down version without all the fanciness, but it tests exactly the same thing. Yes?
Why is it that autism strikes mainly males?
Nobody knows, but there's a theory which won't answer your question, but we'll put it in a broader context. Simon Baron-Cohen argues that there's certain abilities that tend to be more sequestered for males and other abilities that are more sequestered, more focused on females. Social abilities, he argues, tend to be more female than male. So the way Baron puts it provocatively is, to be a man is to suffer from a very mild form of autism. The idea is then that autistic individuals suffer from what he calls extreme male brains. And as such, it stands to reason that they'd be more sampled from the male population than the female population. That's such an interesting issue that, again, when we return to talk about sex differences, we'll look at that in a little bit more detail to see if it's supported by the evidence. Yes?
Does the severity of autism, like, depending on how bad is that mean that the person is not in a certain stage of development?
I'm sorry, tell me that. Is the severity of autism?
Does it mean that they'll stop at different stages of development, or is it always they stop at one exact stage?
It's an interesting question. The question is, how do you think about the severity of autism with regard to developmental stages? And sort of surprisingly, autism can't really be thought of in that way. So it's not like an adult with autism is like a 3-year-old or a 2-year-old. In some ways, somebody like with autism isn't like any child at all, any normally developing child at all. So it's not really a developmental delay in the way that it might make sense to think about certain forms of retardation. On the other hand, when we think about how severe autism is, we do look at things like how much language does a person have. And in that sense, it is related to development. Yes?
What are the chances that someone who's autistic will be able to overcompensate for the deficiencies?
The majority of people with autism, it's a good question. The question is, what are the chances somebody with autism will be able to overcome their deficiencies? Autism is a funny disorder in that there's a lot of media publication and media presentation. Often the people who are showcased in the media tend to be very exceptional. So there's a woman, Temple Grandin, who's autistic. And has anybody here heard of Temple Grandin? She wrote some wonderful books about her experience as an autistic person, but she's very unusual. So a lot depends, to answer your question, how one defines autism, and whether one includes Asperger's syndrome, which is a more mild syndrome as a form of autism. The answer is that the majority of people with autism have severe problems and will not, and at this stage, with this level of therapy, will not lead a normal life.
Just more specifically, what I meant was when you showed the example of Rain Man.
Yep.
Is it that most people who have autism, are they exceptional at math and analytical skills, or are they just better
Right.
relative to their...
The question is about so-called autistic savants. So Rain Man, the character played by Dustin Hoffman, had extraordinary mathematical abilities. And some people with autism have extraordinary artistic abilities or mathematical abilities or musical abilities. And these are amazing. It's an amazing question why they have it. But this is a very small minority. This is a very, it's fascinating that it happens at all, that you can have severe damage, but compensated with some powerful skill. Now I know I'm answering your question, I think, in a better way. But it's actually very rare. Most people with autism do not have any exceptional abilities that go along with it. Another question is, if you believe in modules, if there are modules, what are they? And so far, when reviewing the developmental data, we've talked about two of them, physics and people, an object module and a social module. But other people have argued that there's a special module in your brain for dealing with artifacts, that is, things like tables and chairs and cars and forks. Some people have argued there's a module for sociology, for dealing with human groups, races and classes and so on. Some have even argued that there's an intuitive biology, a common sense biological understanding of the world that's separate from your understanding of people and physics. And in fact, the most dominant proponent of the view is our very own Frank Kyle, Master of Morse College at Yale, who has strongly defended the notion of an intuitive biological module. Final question, just to raise. I've talked in terms of the modular view, but there might also be profound general differences between children and adults, not just specific to how you think about objects or how you think about people or how you think about this or how you think about that, but rather more general. And one claim, which we're going to return to briefly next class when we talk about language, is that there's a very, very big difference between a creature that doesn't have language and a creature that does. And part of the claim is that learning a language, learning to speak, reconfigures the human brain in such a way that is really exceptional and that has no parallel in any other species. And this is an interesting claim, and one we'll talk about. Finally, I want to end with an example from Stephen Jay Gould. Suppose you hate development. You hate developmental psychology. You hate babies. You hate children. They're not cute. They're ugly. You don't want to have them. You don't want to study them. You're annoyed that we have to discuss them. Fine. But there are reasons to study development even if you are not interested in children. Because sometimes developmental studies and developmental data and developmental science can inform questions about adults. And Stephen Jay Gould has a very nice example of this. He asked the question, is a zebra a black animal with white stripes or a white animal with black stripes? Now, you could look at adult zebras all day long and you're never going to figure this out. But if you want to know the answer, I knew it, but I forget what it is. It doesn't matter. But if you wanted to know it, you would look at development. And you'd watch the embryological development of a zebra, and that's how you'd learn the answer to your question. In fact, I'll end with a nice quote. This is by the famous biologist Darcy Thompson, who wrote the book On Growth and Form. And it's sort of the motto of many developmental psychologists and many evolutionary psychologists. So I'll end with this. Everything is the way it is because it got that way. Okay, I'll see you next week.